Hey guys, it's Mr. Collins here, back at it again with the math videos. Today we're going to look at exercise 5C, which is looking at defining functions and how we go about doing that. So, definition for a function is a relation such that for every x value, there's only one corresponding y value. Okay? So if we look at an example here of ordered pairs, we've got -3, 4, -3, 6, and 2 and 8. And we'd say this is not a function because the value of -3 has two separate y values. Okay, so each x value should only have one corresponding y value. So that's one way to look at it. Another way is if you have a graph, or if you can graph a function, you can use the vertical line test to check if an equation is a function by seeing if the vertical line cuts through the graph a maximum of once, it would be a function, as for each x value, there would only be one y value. So looking at this first example here, using the vertical line test at a point, you can see that the graph is the line only intersects the graph once, so therefore, that's y equals x squared is a function. No matter where you draw that line, there's only going to be one x value corresponding with that line. Moving on to this circle, you can see if you pick a point, line here, you can see that it intersects at 2 points. So for that x value, which could be -2, the y value, there are two separate y values. Therefore, this circle is not a function. And for this last one, so the important thing here is it's not just at one point. So if we do the vertical line test here, we can see there's only one x value, one y value corresponding with this x value, let's say x is equal to 4. But if we did the test here, say x is equal to a half, we can see that y value corresponds at intersects here, here, and up here. So therefore, this graph is not a function. So the vertical line test has to work at any point on the graph. Okay, so let's take a look at function notation next. So just making sure you're taking down the notes here, guys, it's really important. So f is simply, much like when we're looking at polynomials, f is simply used to denote the functional operation that has been performed on x to produce a new value. So when you say y, you can replace this with f of x, as y is produced from performing an operation of x. So you can kind of think of f as a machine that when you put x in, it produces a new value. So an example will make this a lot clearer. So write y equals x plus 4 using function notation or x to y notation. Hence find f of 2 and f of minus 1. So it's pretty simple. When you see a y, that's the same as f of x is equal to x plus 4. But when you think about it, y is simply produced from performing an operation on x to produce a new value. That's the relationship between x and y. Okay, so f of x is equal to x plus 4. And then it's a simple amount, much like with polynomial substitution. F of 2, you just substitute in 2 when you have x, is equal to 2 plus 4 is equal to 6. F of minus 1, probably have a go at this one yourself, guys. So pause and have a go. That'd just be -1 plus 4, which is equal to 3. So one more example here. Consider the function y equals f of x 3x plus 4, for all real x, find these following terms. So I'd like you to have a go at the first two yourself. So pause the video and then I'll show you how to do it. Okay, so first one, and this might cut out halfway through, we'll start on the next video. F of 2, just substitute in 2 when you say x is 3 times by 2 plus 4, which is equal to, 3 times 2 is 6, plus 4 is 10. B, so so f of n, so when you're saying x, rather than putting in x, you would just put in n, so that's 3n plus 4. So it looks confusing, but it's not really. I'll go through the last two examples in our next video.